Dried leaves. What can we do with the dried leaves? Before that, ladies and gentlemen, my name is Amesya Sofea Binti Ahmad Sobri. I am representing Malaysia in the category of environmental science with the project called Hydrogen Bank from Dried Leaves. As the world moves to combat climate change, it is increasingly doubtful that coal will continue to be a viable energy source because of its high greenhouse gas emissions. Coal played a vital role in the Industrial Revolution and continues to fuel some of the world's largest economies. But it has an uncertain future as it is going to be depleted over the years. Globally, 81.3% of the electrical production is using fossil fuel as the raw materials, meaning 6.3 billion people is contributing to the release of carbon dioxide gas only by using their electrical appliances in 2020. And imagine how bizarre the amount of carbon dioxide is being released in a year, and it currently causes 670,000 premature deaths a year in China only, and 100,000 deaths in India. To encounter these problems, few countries such as Germany and Japan are taking their actions by using the green hydrogen system, in which it can reduce the greenhouse gas emissions and also other pollutants. This system also is 300% more efficient than coal and will serve us 200% more energy than coal. However, the material used in the hydrogen absorption, which is zeolite, has a low total pore volume and it is quite expensive. And also, it requires a catalyst to ensure the efficiency of the hydrogen absorptions. This new material is very efficient as it has high absorption capabilities, and also it doesn't require any catalyst to absorb the hydrogen gas. Moreover, our sodium CMC carbon aerogel costs 92% less than zeolite, and the materials can be made only by using the dried leaves. What is sodium CMC carbon aerogel, you may ask? Sodium CMC carbon aerogel is basically a carbon structure material with high porosity and filled out with air spaces. To prove the efficiency of sodium CMC carbon aerogel, two tests has been tested on the material, which is GAP surface analyzer, to show the absorption capabilities of the sodium CMC carbon aerogel, and also SEM scanning image to show the porosity of sodium CMC carbon aerogel. The efficiency of sodium CMC carbon aerogel to absorb hydrogen can be proven from the SEM scanning image. If you look at the SEM scanning image of the sodium CMC carbon aerogel, it is very porous compared to the zeolite. Thus, the sodium carboxymethyl carbon aerogel has high hydrogen gas absorption capabilities. To add, based on our calculation, there will be 72 millions of hydrogen molecules will be absorbed in this Singapore. And as you can see in the image, there is a pores inside the pores and inside the pores. And imagine the amount of hydrogen gas that can be absorbed by the thousands of pores in this single bit. Next is GAB surface analyzer test. We conducted the GAB surface analyzer test on 4 samples of sodium CMC carbon aerogel, which have different molarity of the caustic solutions. Let's look at the result obtained from the GAB surface analyzer test displayed in the table. Sample 1 represent 1 mole per dm cube of the cross-linked solution. Sample 2 represent 2 mole per dm cube of the cross-linked solution. Sample 3 represent 3 mole per dm cube of the cross-linked solution. And sample 4 represent 4 mole per dm cube of the cross-linked solutions. The total surface areas of pores in sample 1 sodium CMC carbon aerogel has 37.97 meters square per gram, while for sample 1 zeolite has 0.648 meters square per gram. This shows that sample 1 sodium CMC carbon aerogel has higher total pore surface area compared to the zeolite. The total surface area of pores in the sodium CMC carbon aerogel is dependent on the concentration of the cross-linked solution. Based on the table, if we compare sample 1, 2, 3 and 4, sample 4 has the highest absorption of hydrogen because it has the highest total surface area of pores. If you look at the graph, volume of hydrogen gas that can be absorbed by sodium CMC carbon aerosol is increasing from 9.95 cm3 per gram to 20.02 cm3 per gram, while for zeolite only increased from 0.2 cm3 per gram to 0.77 cm3 per gram. Thus, the result shows that sodium CMC carbon aerosol has higher absorption of hydrogen compared to zeolite. Thus, this shows that sodium CMC carbon aerosol is a better absorbent of hydrogen gas compared to the zeolite. There are a few steps needed to make the sodium CMC carbon aerosol beads. Firstly, you ground the dried leaves into powder. Then, you extract the cellulose from the dried leaves. Next, you add sodium hydroxide solution to the extracted cellulose for the alkalization process, and the mixture will undergo actification process where you add nitric reagent and acetic acid to turn it into sodium carboxymethyl cellulose, or known as sodium CMC. The sodium CMC solution is then dropped twice into the cross-linker solution, and we left it for 72 hours for complete cross-linking process. Then, we filter the mixture to get the beads, and we air dry it for 24 hours. Lastly, beads will undergo pyrolysis process to form sodium CMC carbon aerosol beads. Based on the result of sodium CMC carbon aerosol, we are planning to implement the material in the hydrogen system to replace the zeolite in absorbing the hydrogen gas. By implementing the sodium carboxymethyl cellulose carbon aerosol in the hydrogen system, it can be a catalyst to increase the investment of hydrogen economy rather than fossil fuels. With this, we can produce a clean and efficient energy, as the hydrogen system will produce a large number of energy without any environmental effects. To conclude, ladies and gentlemen, let's create a better future with a more cleaner energy by implementing the sodium carboxymethyl cellulose carbon aerosol in the hydrogen system. To a better future together, or never.